Welcome everyone. We are going to find out the molecular geometry of PCl5, which is known as phosphorus pentachloride, and in order to do so we must find out the hybridization first, and for finding out the hybridization we need to calculate the number of valence electrons present in each atom of this molecule. So now in PCl5 it has phosphorus and chlorine. So the electronic configuration of phosphorus is the inert configuration of neon, and then 3s2 and then 3p3. Its valence shell is the third shell because phosphorus belongs to the third period. Okay, it is a third period element, so its valence shell is the third shell. Okay, how to calculate the number of valence electrons? It is simply the number of electrons which are present in the valence shell. So 2 plus 3 gives us 5 valence electrons. Talking about chlorine, its electronic configuration is neon, the inert configuration of neon, and then 3s2 and then 3p5. Now it is also a third period element, so the number of valence electrons are those electrons, such electrons which are present in the outermost shell, the valence shell, and its outermost shell is the third shell. So 2 plus 5. 3s subshell is having two electrons, sorry, and 3p subshell has 5 electrons. So 5 plus 2 gives us 7 valence electrons, 7 VE. Now let's calculate hybridization. So for phosphorus we have 5 valence electrons, so I'm going to write 5. For chlorine we have 7 valence electrons, so I'm going to add 7. But since we have got 5 atoms of chlorine, so I'm going to multiply it by 5, the number of valence electrons for chlorine into the number of chlorine atoms. Okay, so 5 plus 35, 7 into 5 is 35, gives us as 40. Now I've told you guys before that while calculating hybridization, if the total valence electron of the molecule, because this is actually indeed the total number of the total valence electrons of the molecule. Okay, so if this number comes out to be greater than 8, then we divide this number, suppose we call it x, then we divide x by 8. Okay, x by 8. But if this x would have been 8 itself, or maybe 6, or maybe 4, okay, 8 or less than 8, then we would have divided it by 2. Okay, so this is the rule of hybridization. Now let's calculate. So 40 is greater than 8, we are going to divide it by 8, gives us 5, which corresponds to sp3 dehybridization. Okay, so sp3d hybridization means it has got trigonal bipyramidal structure. So or you can say trigonal planar bipyramidal. Okay, let's draw. You guys will get a better grasp of things. So I said trigonal bipyramidal. So the word itself is quite explanatory. Trigonal, okay, a triangle, any triangle, and bipyramidal, a pyramid on top of this triangle and a pyramid below this triangle. Okay, so let's draw. We have our central atom as phosphorus, so I'm going to write P. Now triangle, let's draw chlorines here. Are you able to see some sort of triangle? Yes, of course. See, chlorine has bonded with phosphorus has bonded with 3 chlorine atoms. You have got 2 chlorine atoms left. Suppose this PCl3, this thing, is in a plane, is residing in this board, okay, and there is a chlorine on top, okay, and there is a chlorine below here. Are you guys able to see it? Here is also a chlorine as well as on top. Okay, so I'm going to depict it on the board because I can't write in space, on space maybe. So you've got a chlorine on top, okay, here, and you've got a chlorine below, okay, below this board, below the table on which I'm writing. So you've got chlorine here. Okay, so you got a pyramid now. See, I'll make you see it even better. Are you guys able to see? The faces of the pyramid are these faces. This is the first face. Okay, the second phase is this one. Okay, and the third phase is this one. This is the third phase. Similarly, there are 3 phases for this chlorine also. So the sp3d hybridization corresponds to trigonal bipyramidal structure. So this is the structure of PCl5. You can even draw it in a simpler format, simply like this. P, Cl, 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 and Cl, and a Cl. Okay, this chlorine, and this chlorine is on the board. This chlorine is on top of the phosphorus. This chlorine is here. Okay, so that's it. This was the structure of PCl5. I hope you guys understood it nicely. I'll see you guys in the next video.